Hello, a very good evening to all, and welcome to my class. Okay, so today is your paper. I expect that your paper had been gone very well, right? So let's discuss some question and the question in which you face some problem, right? So we are going to discuss some questions right here in which you are facing some problem, or we say you are confused about what the correct answer for this question and all. So in this session, we are going to discuss all these questions. I expect you all had a good exam today, right? So let's start with the today's session and discuss each one question in a very detailed way, right? So the first question, that is question number 31. Basically I'm here to discuss only chemistry question, right? Okay, so what the first question state that beta, this is a very simple question and it is basically from the chemistry in everyday life, right? So this is from chemistry in everyday life. First question is from chemistry in everyday life, right? So this is from this chapter. Every year, one questions coming from these chapters like chemistry, in everyday life, environmental chemistry, and all, right? So what the first question state, beta? According to this question, which type of soap contain filter like sodium resonate, sodium silicate, borax, and the sodium carbonate? Right. So basically which type of soap? It is medicated soap, normal soap, toilet soap, or laundry soap. I hope most of you, did this question in a correct way, right? Because this is very simple question. We already discussed when we are discussing about the chapter like chemistry everyday life now, that is the soap which contain the sodium silicate, borax, and aluminum carbonate. Like they are basically falls in the category of laundry soap. Okay, so they are the example of laundry soap. So option C is absolutely correct. I hope many of you did this question correctly, right? Okay. Now, the next question, that what will be the name of the atomic number 114 according to the IUPAC nomenclature and its symbol respectively. So you have to write the you have to write the IUPAC name as well as their symbol, right? So we know that in our periodic classification chapter, we know how to write the atomic, when the atomic number is greater than 100, then how to write the IUPAC name. Okay, so we all know that it's very simple question. When n is equal to 0, then we use the word nil. And similar one, when the n is equal to 1, then we use as, that is un. Okay, and so on. So we have a table like from 0 to 10, and we can use this to write any name, right? Now in this question they ask to write what is the correct name of this following atomic number, that is 114, right? So 1 stand for un, so this is un. Again 1, it means un, right? Un. And 4 means quad, so un, that is quad, right? So this is un quad. So this is for 1 and 4. So this is 1 quad. And after every name, na, last we use IUM. Last what the main thing we use, that is IUM. So the correct name become IUM, that is unquadium. Unquadium. So out of this four, beta, which option is correct? Unquadium. Which option is correct? A, B, C, D. Yeah, that is C. So C is absolutely correct answer for this question. On the similar way, just try to write the name of this, right? That is 101. What is the name? What is the IUPAC name for this complexes? Sorry, for this atomic number, beta, 101. Write the IUPAC name. Again, 1 means un, right? 1 means un. 0 means nil. So that is un-nil. Again 1, un-nil, un-niyam. Right. So this is the correct IUPAC name for this atomic number. So any atomic number whose value is greater than 100, we can use this rule to write the IUPAC nomenclature. Right. So I hope is it clear to everyone, right? Okay. So shall we proceed to the next question? These two questions are very easy. You can easily get the 8 marks, right? These two questions are really easy. Now, this question is very important, right? So try to understand this. This question is also from the chapter, same chapter, that is chemistry in everyday life. So you can't believe now, you have a two question from the chapter, because many of students what they are doing now, they are skipping this chapter because they think, oh, this is not so much important chapter, we can skip them and try to give time to the another chapters. But in fact, this is not the good way to prepare yourself, right? Just do this chapter as well, because this chapter contain a simple question. If you know the some basic concept and the reason behind this, now then you can easily get it 8 marks if the two questions like that coming in the your examination, right? So please don't skip this chapter and try to do this chapter as well, because these are the also important chapter and carry minimum one question or maximum two questions. So you can get 8 marks if the two questions are coming from this chapter, like this paper only, right? So what the question asks, beta, the structure given below is the general structure of the drug used as. So what from this given diagram, just identify which having this type of structure, beta. Yeah, which having this type of structure, that is, yeah, that is penicillin. So penicillin is a very, very common antibiotic, and this diagram is for penicillin, right? So this is for penicillin, right? So this structure is for penicillin, and this is very common diagram, right? So the structure given below is a penicillin, and penicillin itself belong to the category of what? That is antibiotic drugs, right? So this is belong to the category of antibiotic drugs, right? So I hope is it clear to everyone? That is antibiotic drugs. What is antibiotic drugs and all? Okay. So right. Now, so I guess many of you did this question very correctly, right? Out of these, that is, it is whether it is anti-fertility drug, antiseptic drug, disinfectant drug, antibiotic drug. So penicillin belong to the category of what, beta? It belong to the category of antibiotic drugs, right? Okay. Now let's move to the next question. That is question number 34. What would be the major product? Just remember this, beta. This is a general formula of penicillin drug, which is used as an antibiotic, already discussed, right? Now, what would be the major product of the following reaction? You have to identify what would be the major product for this following reaction, right? So just identify, beta, what is the major product for this following reaction, right? Okay, so in this question, just identify this is what is the catalyst used here in presence of what? In presence of this, that is 1, 2, 3. That is 2. What is IUPAC's name of this, beta? That is 2-methyl propanol. So 2-methyl propanol. When we treat this with 2-methyl propanol, then which will form in a major product and which will form in the minor product? You just have to identify this, right? So let's discuss with this, right? Okay. Now, as we see now, when this is treated with Br, right? When the alcohol, we know the simple reaction. Whenever the RCl is treated with the alcohol-like structure, okay. So what the formation takes place, beta? Just like that, when this Br is treated with HO in presence of 20 degrees Celsius through SN1 reaction, right? So through SN1 reaction, the possibility of two product will be formed, right? What that is? That is either this or this, right? So in your option, just observe carefully, either this one, that is 1 and 2, this one or this one, this will be your major product. So out of this fourth option which one having, yeah, that is B. So B is the correct answer for this question, right? Okay, now the next question is the pollutant which come directly. This question we already discussed when we are doing the chapter environmental chemistry, right? So this question is from this topic only, right? The pollutant which come directly in the air from the source are called primary pollutant, right? The pollutant which come directly in the air from the sources, which are called primary pollutant, right? Now, the primary pollutant are sometimes converted into secondary pollutant. Which of the following belong to the secondary pollutant? So you have to identify out of these four which belong to the secondary pollutant. Okay, इसमें आसान क्या है? They already given what is primary pollutant. Primary pollutant means which come directly from the sources, like carbon monoxide, that is a combustion of the incomplete combustion of the vehicle produce CO. Hydrocarbon are produced in the many atmosphere, a carbon, hydrocarbon are also present. NO is also present. NO is also from comes out from the vehicles, uncomplete combustion and all. So out of these four, only peroxyethyl nitrate, that is PEN, also known as beta PEN, right? So PEN belong to the secondary pollutant, right? So secondary pollutant means what? When the primary pollutant is converted into secondary pollutant. So PEN is the secondary pollutant. Just remember this word, right? PEN belong to the category of secondary pollutant. So this is also a very easy question and you easily done this question, right? Now, let's move to the question number 36, right? So let's move to the question number 36. That is, which of the following statement is true for an ideal solution? So we know that what is ideal solution, beta? Ideal solution means when they follow Raoult's law under the entire concentration temperature, or we say in which delta H of mixing is equal to 0, delta V of mixing is also equal to 0. So these are the characteristics of the ideal equation. So first point is the solute and solvent both obey Raoult's law. The solute obey Raoult's law and the solvent obey Handy's law. Now this is not the case. The solute obey, right? The solute obey Handy's law. No. The solute and solvent both obey Handy's law. No. So only out of these four options, only option A is correct. That is the solute and solvent both obey Raoult's law. When they obey Raoult's law, then only this form ideal solution. Ideal solution means the total pressure expected is equal to sum of the partial pressure of A and B. Okay. So this must be equal. When this is equal, then the solution follow ideal. Then the solution is ideal solution. And this equation is given by the Raoult's law. So when the solute and solvent both obey Raoult's law now, then we can only say that the solution is ideal. So this is also very important and very simple question, and they are generally from the chapter solution, right? So I hope all of you did this question correctly, right? Okay. Now, shall we move to the next question? Okay. Okay, so how many electrons per mole of platinum are transferred when aqua regia oxidized platinum? First of all, what do you mean by this term aqua regia, right? Aqua regia means what, beta? That is when the HNO3 is treated with the HCl, right? HNO3 and HCl mixture is known as aqua regia. So the question asks how many electrons per mole of PT, that is number of electrons per mole of PT are transferred when the aqua regia oxidized platinum. So, let's see the solution for this question. Here is the platinum and this react with the aqua regia, that is HNO3 plus HCl. Okay, and this will produce H2PtCl4NO plus H2. Now, total number of electron transfer here now, that is 12. How will you get to know better? Total number of electron transfer here is 12. Just observe it carefully now. That is here the PT is 0, right? And here the oxidation state of PT become what? That is, we know that this is a 3 and H2 having 2 and this is X and chlorine having how many beta? Chlorine having how many? -1, having -6 into -1. So this will become, right, beta? This is 3 outside and this is the 2 plus X minus 6. So X comes out to be what? X comes out to be is equal to 0. If you put is equal to 0, then X comes out to be 6 minus 2, that is 4. So 1 mole having 4, right? 1 mole having 4. So we have total, we have how many mole beta? 3 mole of platinum now. So 3 mole of platinum produce 12, that is 12 mole. So 1 mole of platinum will produce beta 12 upon 3, that is 4, right? So the number, how many electrons beta? The 4 electrons per mole of the platinum are transferred when the aqua regia oxidized platinum, right? So I hope this is very simple question. If you know the reaction now, then you can write this question. So this is totally based upon the number of electron transfer, and right? Okay. Now, next move to the next question, that is question number 38, right? So how would you expect the bond strength to change in the series when we move from C2 to C2 negative and C2 negative to C2 negative, right? I share one trick with you when we are discussing now MOT, that is chemical bonding. Then I'm discussing one trick with you all guys. What the trick this is, how to calculate the bond order, right? So we can calculate bond order by using a simple formula, right? Like that is electron sum, and this is bond order. When the electron sum is 10, 11, 12, 13, 14, 15, 16, 17, and 18. Bond order will be, that is corresponding to 10 electron sum. Bond order will be 1, 1.5, 2, 2.5, 3, 2.5, 2, 1.5, and 1. This trick I already discussed with you. Okay. So this trick I always discuss with you, and I already told you that whenever the questions were coming from such topic, try to use this trick, not go in a depth way that draw the energy diagram and then calculate number of bonding and number of anti-bonding. Yeah, this is also a correct way and you'll get the answer, but it consume time. Okay, so always prefer, whenever the electron sum is lie between 10 to 18, just use this trick and you get the answer in a just a second, right? Now if I'm talking about C2 having how many electron beta? That is 12. 12 having bond order of 2. Right. Now we move C2 negative. C2 negative having 13 electron. 13 electron having bond order 2.5. Right? Okay, corresponding to 13. Now, if I move to C2 negative, that is 14 electron. 14 corresponding, that is 3. So what observe you in bond order? What observe you get better in this bond order? That is bond order increasing now from 2 to 2.5, 2.5 to 3. So we can say that the bond, how it squares the bond strength. So if the bond order increasing, if talking about whether it's a single bond, double bond, triple bond, obvious triple bond having more, more stable and having more bond strength. So get stronger than the weaker, gets weaker, gets stronger, and gets weaker then stronger. Okay, so out of this, which one is the correct according to you, beta? Yeah, gets stronger, because you can observe here na bond order will increase from 2 to 2.5 and 2.5 to 3. So we can say that bond become stronger as we move from C2 to C2 negative and C2 negative to C2 twice negative, right? I hope is it clear to everyone. Okay, right. Now, this is also another way to solve this question, but always use the trick, right? If you know this trick, then you have no need to write like this. Just by using trick, you can calculate. Now, next question 39, and this is good question, I guess. Okay, this is good question. So, try to learn this from this question as well. Okay. So what the question state, beta, that according to the question, consider a solution consisting of the following two buffer system. Okay, H2CO3 plus SCO3 negative and having pK value 6.4. Similar, H2PO4 to HPO4 twice negative and having pK value 7.2. At pH 6.4, when the pH becomes 6.4, which one of the following is true for the concentration of acid and conjugate base present? So you have to calculate the which out of these four options, which represent the true about the concentration of acid and conjugated base when the pH becomes 6.4, right? So let's discuss this question 39, then we move to the 40 question, right? So we know that at pH is equal to 6.4, as in case of carbonic acid, that is to CO3, pH is equal to pK. pH is equal to pK. It will be only when the weak acid is equal to conjugate base, right? That is in case of H2PO4. Whenever pH is equal to pK means what? It will be only when the weak acid is equal to conjugate base, right? Or in case of H2PO4, we know that H2PO4 behave like this. Now we know this formula, that is pH is equal to pK plus log this one. So just put the formula. We know the pH is equal to 6.4, pK is equal to 7.2, and just try to calculate the value of this. So this value comes out to be 6.4 minus 7.2, something negative. So this value comes out to be negative, or we say it is less than 1. If this is less than 1, then HPO4 twice is must be less than H2PO4 negative. So we can say that out of these, which one is correct, beta? That is option number Yes, option number D. Yeah, this one. So this one will be absolutely correct answer for this question. Okay? Right? Okay. So this is absolutely correct for this question. Okay. Now, let's move to the next question. That is question number 40, right? Two structures are given. That is structure one and structure two. You have to identify whether it form constituent isomer, whether they form identical isomerism, whether they form enantiomer, or whether they form diastereomers. Okay. So now, if you assign the RS nomenclature, now what is RS nomenclature, beta? RS nomenclature we designate by using CIP rule. So if you know this rule, and what the rule state that always take whether you take rotation anti-clockwise or clockwise according to their CIP rule. CIP rule means give preference to those which containing the higher molecular masses, right? So these two are, because they form SS and they form SR. So these two are diastereomers in nature. Okay. So assign RS nomenclature to the chiral carbon, and these formation, that is SS or we say SR formation takes place. So these are the diastereomers. So just try to learn this. This show the diastereomers nature. Now, this one is also very important question. That is, this is from basically coordination chemistry, beta, right? So according to this question, which of the following complexes can exhibit optical isomerism, right? So we have to see the optical isomerism, right? The first one is cis, and that is tetramine chlorido-cobalt, right? And the similar base is trans and cis. So we have to identify out of these, which will undergo optical isomerism, where En is ethylene diamine, right? Now, here, just observe the configuration carefully. We discuss whenever cis is present in CO, or we say, we can learn like this now, M A2 B2, right? We can learn like this, that is Ma2 B2. So this will definitely show what? That is optical isomerism. So what is the condition to show optical isomerism, beta? The condition is mirror image must be non-superimposable, right? So let's see. Okay, so these two, that is cis CON2 Cl2, their mirror image are non-superimposable, right? Their mirror image are not. What is non-superimposable means? For example, like this. Okay, and I put this as well. So this is our, our thumb. This in this direction. If you put just above this, then this represent these are non-superimposable in nature, right? So these are the non-impossible. Just like that, these structure, that is COEN2, Cl2, they are also non-superimposable mirror image of each other. So this will show optical isomerism. So these are the criteria whether the compound will show optical merism or not. I hope is it clear to everyone, right? Okay. Now, in this question, you have to identify the concentration time dependent for the first order reaction is shown in the graph. At which point on the curve, the rate reaction is fasted. You have to identify the point on the curve at which the rate of reaction is fasted, right? Now, so if you just observe the graph carefully, then you get to know that is molar concentration decreases as the time goes on. So we know that if I'm talking about the first order reaction, so what is the expression for the first order reaction, beta? That is T is equal to 2.303. This is K, this is log, this is R naught upon R. So this is the integrated rate equation, right? This is the integrated rate equation for the first order. Okay. Now we also know that for the first order, R is equal to K and the concentration, right? R rate of reaction is equal to this into my concentration. That is this one, right? Okay. Now we know that as the for the first order reaction, the speed of the reaction is fastest at the beginning. It means when the start reaction just started, then their speed is maximum, right? Then their speed is maximum. So out of these 3 points, A, B, C, in which देखो यहाँ पे क्या है टाइम, दिस वन, यहाँ पे टाइम क्या है, दिस वन। इफ आई एम टॉकिंग अबाउट ए ना, यहाँ पे टाइम सबसे कम है, मिनिमम टाइम है, दिख रहा है आपको, ये मिनिमम टाइम है। सो एज द this is first order reaction, and we know that first order reaction are initially very much fast. Okay, so the point A represent the rate of reaction which is very fast. So out of this fourth option which one is correct, that is option number B, right? So this will represent option number B, that is point A. Point A represent the point at which the reaction is very fast, because this is the first order, and for first order the reaction is fast at the first starting of the reaction, right? Okay, now so we know the we already know the discuss the solution for this question, right? So I hope you understand the question. For the first order, the rate of reaction is faster at the beginning. Now question number 43, this 43, 44, these two questions are very easy, right? The first question states that you have to identify, what you have to identify, beta, arrange the following on the increasing order of acidic hydrogen. So we know that which hydrogen is more acidic in nature, having sp carbon electronic configuration, then sp2 and sp3 will be the minimum. So what is the order for the electron activity in terms of carbon beta? That is sp is more, then sp2, then sp3, right? So arrange the following in the increasing order of their acidic hydrogen. This will be the criteria. Now out of these four, which of the following having sp electronic hybridization beta? Just try to see this. Which having sp? Yeah, that is number fourth. Yeah, this carbon having sp hybridization, because carbon carbon triple bond here. Right, very good. Now next is beta. That is if I'm talking about alcohol and phenol. Now obvious phenol, this is what? Benzyl alcohol. This is what? This is benzyl. This will be much more after this and this. So option A, right? So option A is absolutely correct, right? Option A is absolutely correct. That is the one, two have greater than one, three is greater than two, and four is greater than three. So four having a maximum, increasing order of acidic hydrogen. It means four having the maximum chances to give acidic hydrogen as compared to rest of all other three, right? So and what the concept here, beta? The concept here, the carbon having sp hybridization having more electron activity as compared to sp2 and sp3, right? So this is the correct option. That is question number for question 43. The correct answer is option number A. Now, which of the following, question number 44, that is which of the following is an example of Stefan reaction, right? So you have to identify which of the following is an example of Stefan reaction. ठीक है, तो कौन है स्टीफन रिएक्शन का एग्जांपल बेटा? दैट इज द फर्स्ट ऑप्शन, व्हेन द आरसीएन इज ट्रीटेड विद AH ब्यूटाइल H2O, when the CH3CH2C9COO is treated with dibyl H, when RCN is treated with SNHCl, right? And then the formation of aldehyde. Yes, this reagent is an example of Stefan reaction. Stefan reaction, right? So this is the correct answer for this question. That it means it is very simple question, and basically came from the name reactions, like what is Stefan, what is Hunsaker. So these type of questions are also coming better, like identify the reagent used in this reaction. Yeah, what is the product here? So remember the name reaction as well, right? These are going to be very important. Okay, and this will definitely give you 4 marks for such question also, right? So out of this fourth option, which one is correct, beta? That is number 3. Whenever the RCN is treated with SNHCl, the formation of RCHNH, and upon acidic hydrolysis, they will form RCHOaldehyde. So this is all about the Stefan reduction, or we say Stefan reaction, right? Let's move to the next question. That is question number 45, right? Okay. in this question, what is the formula and the method of preparation of hypophosphoric oxyacid? So these all are the hypophosphoric oxyacid. Now you have to identify what is the formula and method of preparation of hypophosphoric oxyacid. Okay, how will you prepare this? Now we know that red phosphorus undergo disproportional reaction. Okay, P4 is example of red phosphorus. Now, red phosphorus undergo disproportional reaction with alkali to form H4P2O6 to form H4P2O6 and pH3 and pH3, right? And pH3. Just wait. Yeah. So what formula and method? Like if you want to prepare this now, if you want to prepare, then the red phosphorus undergo disproportional reaction with the alkali to form H4P2O6 and pH3. So which one is the correct option for this question, beta? Yeah. Tell me. That is question number 45. Which is the correct? That is D. Right. So red phosphorus react with to form this one. Right. I hope is it clear to everyone? Okay. Now, which of the following curve in accordance with the Friendlich adsorption isotherm? So you have to identify out of this given four, which curve is correctly represent, right? Which curve is currently represent this. So we know that for Friendlich adsorption isotherm, what we know better, that is x upon m is equal to, or we say proportional to 1 upon n, right? Now, if I write x upon m, we can say that proportionally constant k, and this is p raised to the power 1 by n. Now, if you take the log both sides, then this will become log x by m, right? And this will become 1 upon n log p plus log k, right? Just use the formula multiply property. Whether when you multiply a log, two values with log, then it will become addition of this, right? So 1 upon n log p plus log k. Just use this formula. Now you can see that is 16C question. This one is absolutely correct. How we can say that, beta? That is log x upon m. Log x upon m. So this is in the y-axis. This is the slope. What is the slope, beta? That is, this is slope into this represents the x-axis plus this is intercept, right? So here the slope comes out to be 1 by n. Here the slope is 1 by n, and here what is x, beta? So x is equal to log 1 upon n is the slope, and this 1 upon n log p. So just put it here, right? Log p represent x here. So this is log p. Okay. So this is how you can solve this question. So out of this four, which option is correct, beta? That is C. This one. That is, it is a graph. Which of the following curve recorded in this curve? That is C. Log x by m is equal to log p into the slope plus log k, which act as an intercept. So always they have an intercept. So apart from this correct answer, now you have just observed the other three options as well, in which there is no intercept is given. So these are the not correct. The correct answer is only third option, right? Okay. Now, shall we move to the next question? Right. Now, out of these two, which of the following complexes in the order of value delta O is correct? Okay, delta O is correct. Delta O is what, beta? Already discussed in the coordination chemistry chapter. Delta O is splitting energy. Now, what is splitting energy, and what is the main criteria behind this, beta? We know that if the ligand is strong ligand cause more splitting. Then splitting will also more if the ligand is strong. Now, one more important factor, that is the configuration, that is whether it will be 3D, 4D or 5D. If the element present in 5D, then this will cause more splitting. Okay, and then delta O also become increase as well. So this is another important factor which also decide the splitting, whether the splitting is more or less, right? So out of these, now you just observe option number A, both having NH36 and NH36, but the number, wait, look at the central metal here, that is CO and RS. So in this, they having electronic configuration lie between 4D, 5D. So obvious, they RH lie in the category of 3D, 4D, sorry, 4D and 5D. So obvious, as the 4D, 5D picture comes into the picture, they also cause the energy, octahedral splitting energy also increase. So the correct answer is for this question is A. This one is the correct. I hope is it clear to everyone? Right. Now, out of these questions, 48, 49, and 50, okay, just out the following oxides of nitrogen, how many of them are neutral oxide? So you have to identify out of these how many of are neutral. Yes, beta, just give me the answer because this is very simple question. So I accept from all of you that you should, just give the correct answer. I hope you all did this question because this is very simple question. You just pick out the nitrogen number of nitrogen, they are form neutral oxide, okay, which will form neutral oxide. So just pick out the correct out of these given option. Okay, so which will be going to be neutral oxide, beta? That is N2O and NO. Yes, जिसने भी ये किया है N2O and NO बहुत सही है. They are absolutely correct. So these are the correct option. For example, it means 48 questions having which option is correct, beta? That is A. That is number of neutral oxide is only 2. Why? Whether it should be a N2O or we say NO. So only 2 oxides are present for this. Right? Okay. Now next move to the next question, that is 49 question. That is the principle involved in paper chromatography, right? So what is the principle involved in the paper chromatography? The principle involved in the paper chromatography. Okay. So out of this 4 option, whether adsorption, partition, solubility, and volatility. There is nothing to do with the term volatility. Volatility. Okay, so there is no mean of volatile or anything. Solubility also doesn't play any important role in the paper chromatography. So one important thing is there, partition. This will represent. We know now. We just So this will represent, that is partition. So partition play an important role in paper chromatography, right? So out of this 4 option, the principle involved in the paper chromatography is beta partition. So partition play a very exclusive role in a paper chromatography. Now, next move to the next question, that is the purpose of the salt bridge. We all know that salt bridge, we use this in electrochemistry, right? We have a two different solution having two different electrode. So we use a U-tube shape like this. Okay. So this is called salt bridge, right? So the question asks, what is purpose of using salt bridge? Why we use salt bridge? The first option is it's allow electron flow, it's allow all chemical reduction, whether it is allow chemical oxidation, yeah, allow ion. So out of these 4, according to you, beta, which one is correct? Whether it will allow electron flow or it will allow ion flow. Yeah, because why I say only these 2 points now, because here B and C option are very much clear, that is all chemical reduction. Okay, and there is nothing to do with this chemical reduction and oxidation with the salt bridge. Salt bridge is basically used for maintaining the neutrality of the circuit. Now out of these 2 options, because maybe some student getting confused in these 2 option only, that is whether it allow ion flow only or they allow electron flow as well, right? So please let me know what the correct answer for this question, beta, or what you did to in your today exam. Which one? That is option A or option D? Yeah. So most of the student, go with option number D. Why? Because salt bridge first function of salt bridge is to maintain the electrical neutrality, and the second more important, and this is one of the most important function of salt bridge, is that it's allow ion flow. Okay, if the salt, for example, salt bridge consists of salt like KCl having positive charge and negative charge. So these negative attract the positive one and this positive attract the negative one. So accumulation of charges is not taking place. If this is not done, then the accumulation of charges taking place and the flow of ion will stop. So this will allow the ions to flow. Okay, so this allow ion to flow. So we can say that the purpose of the salt bridge is to allow ion to flow, not allow electron flow, right? So I hope, is it very much clear that what is the purpose of salt bridge we use here? Okay. Now, next move to the question number 51. This one is very important question. Then so we have to solve this question, right? Because this is numerical based question. So you have just to write the answer in the nearest integer. So what the question state? When the ethanol is treated with, right? When the ethanol is treated with what? When the ethanol is treated with KMNO4, right? When the ethanol is treated with the KMNO4, it will produce HC2CH3O2 plus MnO2 plus KOH plus 2. Is the unbalanced equation. Unbalanced equation if 5 gram ethanol and excess amount of aqueous KMNO4 are reacted and a 5.5 gram of SC2H3O2 result. What is the percentage yield in the nearest integer? You have to just tell what is the percentage yield in the nearest integer. We know that from the principal conservation of atomic conversion on carbon, we know that that is the 3 mole of, okay, that is the 3 mole of 3 moles. Just try to understand this question, okay, because this is an important question. That is the 3 moles of C2H5 and OH will give 3 moles of HC2H3, right? HC2H3 and O2, right? Now, what is the moles of this H2CO3? So moles of HC2H3 and O2. We know that how we'll calculate beta. That we will calculate moles mass upon molecular mass. So is the unbalanced equation if 5 gram of ethanol and excess amount of aqueous KMNO4 are reacted. Okay, so this way 5 by molecular mass, that is 46. Now, moles of this is this is the theoretically value. This is theoretical according to the question. Now, experimentally value like experimental value comes out to be like it will become 5.5 gram, right? Divided by 60. So what is the percentage yield beta? What formula we use to calculate the percentage yield? That is 5.5 upon 60 into 5 into 46 into for percentage we use 100. It comes out to be 84%. How many percent beta? That is 84%. So let's discuss this question again, because in this question they are saying when the ethanol is treated with KMNO4, then the formation of this takes place. Now is the unbalanced equation if the 5 gram ethanol and excess amount of aqueous KMNO4 are reacted and 5.5 gram of H2C2O3 are formed. So experimentally how it will form beta, that is 5.5 gram upon 60. Then what percentage yield in the nearest integer? That is 5.5 upon 60 into 5 divided by 5 into 46, right? It means this one. So percentage yield means what? That is experimentally how many you'll experimentally how much you observe and divided by the theoretical value. So you'll get the answer. Just like this is 5.60 and just divide with. So divide in the sense it will become 46 upon 5. And for percentage we use 100. So by solving this we get 84, right? So this is the correct answer for this question, that is 84%. Okay, I hope is it clear to everyone. Okay, now let's move to the next question, that is question number 52. What the question number 52 state beta? That is a face center cubic unit cell contain 8x atom at the corner of the cell. So we know that 8, the contribution of the corner of the cell is equal to 1 by 8 into it. Total number of atom is 1. And 6 Y atom at the faces. If the empirical formula of the solid is XaYb, then what is the, what is B by A? So just first of all, you have to calculate the number of atoms present at the X corner and Y, okay, the face center. After this, by using empirical formula, we can predict whether it is a B or A, right? So let's start. We know that at face center contribution is like that. That is 1 by 8 into 8. That is equal to 1. Okay. Next, it will state that uh, at the corner of the cell and 6 Y atom at the faces. We know that face means what? That is at the face contribution is 1 by 2. So that comes out to be 1 by 6. Sorry, 6 into 1 by 2. This will comes out to be that is 3. So number of atom at the face is equal to 1 and number of atom at the face is equal to 3. Right. So what is the combination here, beta? The formula become X1 and Y3. So this is the molecular formula. So what is the ratio between this and this is B by A beta? This comes out to be 3 by 1, which is equal to 3. Right. So this is very simple and this is important as well. Because we all know that is contribution at the corner is 1 by 8. Contribution at the face is 1 by 2 into 6. That is 3. So empirical formula comes out to be XaYb. And XaYb here is X1 and Y3. So what is the ratio B by A? That is 3 by. I hope is it clear to everyone? No problem in this question? Right. Now, question number 53. What the question number 53 state, beta? Okay. According to this question number 53, it state that calculate the strength in gram liter of 10 volume solution of hydrogen peroxide. So this question is basically from the hydrogen chapter, hydrogen peroxide at 273 Kelvin and 1 bar pressure. And report your answer divided by 10. And you have to write the answer just by divided with the 10. Okay. So we already know that 10 volume of, right, that is 10 volume of solution of H2O2 means what? That is 1 liter of this H2O2 solution will give 10 liter of oxygen at STP, right? We know that whenever the decomposition of H2O2 takes place, it decomposes into O2 and H2O. So 2H2 means 2 into 34, that is 68 gram. And O2, it means at STP, it will equal to 22.7. So 68 gram produce 22.7 liter at STP. Now, on the basis of above equation, 22.7 liter of O2 is produced from 68 gram of H2O2. Obvious. It means 68 gram of H2O2 will produce 22.7 liter of O2 at STP. For 10 liter of O2, the STP produces this, that is 29.9, or we say 30 gram of H2O2. Therefore, the strength of H2O2 in 10 volume is 30 gram per liter, or we say, but divided by 10, it will become beta 3%. So the final answer is 3%, right? So the final answer is 3% solution, right? So we can write this as 3. I hope is it clear to everyone? Okay, that is 10 volume solution of H2O2 means 1 liter of H2O2, right? And solution will give 10 liters. So obvious 68 gram gives 22.7 liter. So 1 liter means what? 1 liter means 68 upon divided by 22.7, right? And similar basis we calculate for this, then we get the answer 30 gram per liter, or percentage we say 30% H2O2 solution. Okay, is it clear to everyone? Right. Question number 54, right? Question number 54. What the question number 54 state, beta? According to question number 54, which of the following, how many compound can undergo aldol condensation? So aldol condensation, what is the criteria to undergo aldol condensation, beta? Only having alpha hydrogen. So those having alpha hydrogen only undergo aldol condensation. So out of this, which having alpha hydrogen, this having no, this having no, this having no, this having no, this having, yeah, because this is alpha carbon, right? So it having alpha hydrogen, right? CHO, so it having alpha hydrogen. So out of this, only option number 4, yeah, this will undergo aldol condensation because they having alpha hydrogen, right? And it's a very simple question, right? Now move to the question number 55. Shown below are the partition of orbital diagram represented the ground state electron configuration of the certain element. If X of them violates Pauli exclusion principle and Y of them violates Hund's rule, then what is X multiplies Y? Okay. So according to X stand for Pauli exclusion. According to Pauli exclusion principle, no set of two quantum number having same, no set of electron having the same set of quantum number, right? So if I'm talking about option one, right, in this 1 1 1 2, this is the force of which law? In a orbital, though electrons must be there and these two must be in opposite sign. This principle is according to this Hund's rule or Pauli exclusion principle, right? Tell me. This is, yeah. Huh. Yani according to Pauli exclusion principle, they state that no two electron in the atom have the same four quantum number. In other words, only two electron may exist in the same atomic orbit. Okay, and these two electrons must have opposite sign. So just look at here. This one, A, B, C, D, E, and this one. This will, this will violate Pauli exclusion principle, because just observe now, that is 1 2 3 and 4 and 3, these two electron having a similar orientation, both having s plus 1 by 2 only, plus 1 by 2, which is not possible. It will be plus 1 by 2 and minus 1 by 2, clockwise and anti-clockwise. So this violate which law? Beta, Pauli exclusion. And the last one is, well, this one also violate Pauli exclusion. So x is equal comes out to be 2 here, because in these two they violate Pauli exclusion principle. Now, according to the Hund's rule, they state that always electrons are filled in a such a way, like if having three orbital, then first electron fill here, second here, third here, then fourth here. Not like this कि एक and दो दोनों यही भर दिया, no, and then three. This is not the correct way, right? So this is not the correct way. This is the correct way. So which of the following y of them violates Hund's rule? So let's check with the two, that is 1 2 and 3. Then this one, so this will violate, okay. And next 1 2 3, this will also violate Hund's rule. Now this is 1 2, this will also violate, and this is 1 2, this will also violate, right? So this will violate the which, that is, okay, it means it most of the configuration, that is number of parallel spin, that is B, or we say D and E, voids Hund's rule, right? Which one is B, D, and E, beta? This one. Let me mark here with star. That is B, and this is D, and this is E. These three, right? These three violate which? This one. Now, what is the correct answer then, beta? That is multiply this. That is a 3 into 2. That is 6. Right? 3 into 2. That is 6. So total is 6. One more important note here. Yeah, this one is the correct way. So this will violate the which rule later, beta? Hund's rule. Hund's rule and Pauli exclusion principle. Right? Okay. Now let's move to the next question. That is question number 56. Right? What the 56 question asks, beta? You have to identify, determine the freezing point, that is nearest integer of a 1 mole per kg aqueous solution of a weak electrolyte, that is 7.5% dissociate into 2 ionic ions in K. Give Kf of the water is equal to this. Now we know that for the 2 ions dissociation, it will comes out to be A plus and B negative. Now, this value is already given, that is at equilibrium 1 minus 0.075, right? So this is 0.075 and this will be 0.075. Formation takes place. Now we know that what is I? I is comes out to be 1 plus 0.075. Just, take it, then you'll get this value. This become 1.075. Now we know that what is TF. Can you explain what is TF, beta? That is freezing point of the solution. That is TF minus TF naught. Okay, freezing point depression is equal to I KF into M, KF into M, right? So it will become, beta, it will become what? That is here I is equal to, here I is equal to what? I is equal to 1.075. Kf is equal to 1.86. And what is molarity here, beta? That is 1. This comes out to be what? It comes out to be beta or around in nearest integer 2 degrees Celsius. Right? So this is delta Tf. So this is the required condition. Okay. I hope is it clear to everyone? So this is the required answer for this question. Okay. You have to calculate this Tf. Okay. Now let's move to the next question number, that is 57. How many total moles of electron are transferred when the 1 mole of CrO2 oxidized to Fe2 plus 2 to Fe3 plus in the acidic medium? So this question is from redox reaction, right? So we know this reaction now, when the Cr2O7 twice negative is treated with 6Fe2 plus in the 14H plus, the formation of this takes place 6,3. So how many electrons, beta? That is, yeah, here the number of electrons 6 into 12, 12. Here 6 into 3, 18. So number 6 number. So correct answer for this question is 6 only. Right? Now, let's move to the question number 58. In the above diagram of the system, from the initial state A, P1, V1, T1 goes to the final state C, P2, V2, T1 from the 3 different paths. Path 1 is from A to C, path 2 is from A to B, C is from A to D to C. Now, how much heat transfer from this to this? Now, what is the correct beta? Because we know that from A to D, the path is from A to D. Just remember this. From A to D. This is adiabatic curve. And we know that for the adiabatic Q transfer is 0. For adiabatic, Q is always 0. So the correct answer is 0. Now, which of the following species are polar? So you have to identify polar. So ClF3, NH3 and water, these all are polar. So these are very simple questions. So out of this, only three, these three are the polar. Okay, which of the following orbitals are not, which of the following orbitals are valid? So yeah, 2px is valid, right? And 4pz is valid, 2py is valid, 4dz square is valid, right? So these are the valid orbital. 2px, 4pz, 2py, 4dz, right? 2dx square is not possible because d orbital routes when the principal quantity number is minimum 3. So these are the correct. Okay, so out of these, only this 1, 2, 3, 4, and one another now, that is 1s, right? So total number, that is 5. So these 5 orbitals are. So I hope you understood this, and understand what the pattern of the question and which type of question basically are coming in your examination. This type of question only you'll see in your coming examination for JEE as well, right? So just prepare this as much as you can and try to solve the question, try to learn the concept as well. Let's meet in the next class, and till, take care and try to solve questions and just study in a cool way, right? So let's meet in the next class. Till, take care and